In this lesson, we'll be talking about mechanical engineering career skills. After completing this lesson, you'll be able to overview the future of work, categorize skills, abilities, and knowledge, describe career crossover skills and skill gaps, and identify future career skills. When we talk about future career skills for a mechanical engineer, we first need to take a look at the past. Tasks such as drafting or designing specifically for manufacture are things that are now underneath a mechanical engineer. The advent of tools and technologies that make this a much easier task for engineers to accomplish has seen these skills being brought underneath the mechanical engineering umbrella. When we think about future skills that a mechanical engineer will need to possess, we need to take a look at the current and emerging technologies. We're starting to see a lot more additive manufacturing tools become commercially available, as well as things like machine learning, generative design, and simulation-driven design tools. These tools are beginning to make their way into the engineering career, which means that mechanical engineers need to be up to speed on them. Let's focus on the types of engineering degrees. We're going to be focusing on mechanical engineering, but things like electrical and aerospace are very similar in nature, and we're seeing a lot of crossover between these different types of engineering degrees. When we're talking about mechanical engineering specifically, that engineer can focus on the broad topic of mechanical, but we also see specializations or subsets such as electromechanical or hydromechanical emerging inside of our job skills. These will require specialized tools that can help that engineer perform the job. Jobs in general will require knowledge, skills, abilities, and work styles. Some of these will be universal and some of these will be very specific. If we talk about work styles, these are things like dependability, attention to detail, and leadership. These are going to be somewhat universal, but different careers will require different work styles. When we talk about abilities, these are things like deductive reasoning, number facility, and written comprehension. Again, the majority of these are going to be universal across the board, especially if you're in some sort of technical role, whether it's engineering or some other field that requires most of these abilities. Skills dive a little bit deeper, and we get into things such as complex problem solving, critical thinking, and even time management. And lastly, when we talk about knowledge, this is the area where we start to see engineering and design topics. So we have mathematics, design engineering, and physics. These are all different types of knowledge. If we take a look at these skills and competencies, the pyramid here that we see will give us a little bit of an insight as to how these skills or competencies, which are the skills, knowledge, and abilities that are required to achieve a certain type of outcome, will really work together and how they unfold in a technical role such as a mechanical engineer. We're going to focus specifically on construction and manufacturing because these are two types of careers that we've seen in the 21st century falling behind the technology that's available. So when we talk about construction and manufacturing, these are seeing a growing worker shortage because the technology skills gap is increasing. As the adoption of new technology increases in these construction and manufacturing industries, we're starting to see these skills and competency gaps because the current workforce is not being trained on the new technology. The speed of change is also impeding a shared understanding of what these skills actually look like. So there needs to be a timely refinement of the workforce development programs to match these demands. If we take a look at the pyramid, at the bottom in blue, we see things like basic literacy, workforce readiness, and workplace ingenuity. These are things that are required to succeed in the industry as a whole. But as we move our way up the pyramid, we see things like analytical thinking and digital literacy, which are transferable across many different industries. But at the very top, we see things like techniques and tech tools. These are faster changing. As new technology is increased, we see that the change in this top section of the pyramid is happening much more rapidly. These are also more specialized, which means they're not transferable across many different industries. Let's take a look at automation and machine learning. In the past 5 to 10 years, we've seen a machine learning engineer career skill emerge as one of the forefront skills that are required of new engineers. This is because the automation and machine learning technology is becoming more available across many different industries, and the greater need for a machine learning engineer is out there. If we take a look at the worker tasks in the US economy from the 1960s to today, we see a rise in these non-routine analytical and non-routine interpersonal tasks, while things such as routine manual and cognitive tasks or even non-routine manual tasks are starting to decrease. So how is this affecting the job market in the US? Well, specifically in the manufacturing industry, we've seen from 2015 to 2018 an increase in the number of days it takes to fill a job, leaving over 500,000 open jobs in that sector. One of the biggest factors in this is the skill set is shifting. So new technologies are being introduced, and the current workforce and even new workforce is not trained in those skills. Sticking with the manufacturing industry, we're seeing a 1.5% growth in the next couple years. Now, this means that the large number of open positions in that sector are going to increase because we're seeing a growth and a higher need for those to be filled. So this means that almost 2 million new jobs are anticipated to be created in manufacturing over the next decade. This is a large number of positions that need to be filled, which means that workers need to be trained in these skills. We also see that 47% of today's jobs might be gone in the next 10 years, and this includes 20% of assembler jobs in manufacturing. So there's a higher need for skills in the manufacturing industry to help communicate and program the machinery or the techniques that are used. However, we're seeing a decrease in some of these jobs as the automation begins to take effect and tasks that are repetitive in nature, such as assembly, are getting moved to more and more automation. So when we take a look at the trends and some of the constraints, we see first that there's a negative perception from students and parents towards the manufacturing industry. This is reported as the second greatest cause in the skills shortage. For example, only 6% of Gen Z in the UK would consider a career in manufacturing, while 9% would consider a career in construction. It's also apparent that in both construction and manufacturing, the current workforce is aging faster. There's going to be 41% of the current construction workforce that will retire by the year 2031. And lastly, we see that almost 2.7 million jobs in manufacturing are anticipated to open due to that retirement. So how is this playing out globally? We've already taken a look at the US, and we've seen that they're facing a skill shortage of 2.4 million qualified workers in the next decade. In Europe, 40% of companies report difficulties in hiring as graduates that are leaving higher education don't possess the skills required for their positions. And in 2015, China graduated 600,000 engineers, but only 1 in 10 were actually ready to work. They call this the supply paradox. So how does this correlate with the increase in education? Well, as we take a look at the automation of certain tasks in the manufacturing industry, for those with less than a high school education, 44% of their tasks are highly automatable. This means that in the next decade, we're going to start to see more and more of these roles decrease, and more of the roles where we're interacting with the machines and potentially programming the machines are going to be on the rise. So as we take a look at this, those with a high school degree have a 19% overlap with automation. Those with a trade school certificate, 8, associate's degree, 6, and all the way down into the higher education, with bachelor degree being 1% and graduate degree having no overlap at all. There is some good news, as industry players are starting to invest in reskilling their current workforce. Amazon has invested $700 million to retrain a third of its U.S. workforce by 2025. Stanley Black & Decker has opened advanced manufacturing facilities for upskilling. And NASSCOM joins hands with IT Ministry to reskill India's workforce. Government is also taking note. In the U.S., Congress reauthorized $1.2 billion in career and technical education programs. The UK government is investing $60 million annually in technical education in addition to $78 million for reskilling the future of work, and China will finance vocational training with 100 billion yuan, or about 14.8 billion US dollars, from the country's unemployment insurance fund, and this is going to help upskill their current workforce. So what are the next steps? Nobody can perfectly predict which tools will be used and which tools will fall by the wayside. But we've seen growing trends in manufacturing technologies and generative design, as well as simulation-driven design, to be confident in knowing that those tools are going to be required of mechanical engineers in the near future. This course is used as the foundation or building blocks to prepare you to use Fusion 360 for mechanical engineering tasks. We've also included some honors assignments giving you access to additive machine programming, automated toolpath creation, inspection probing, and generative design. So understanding what those new or future technologies look like and how to apply them will help you identify whether or not those skills will be required in your specific job role or industry. So make sure that you take the next steps and understand what technology has to offer by going through our honors assignment at the end of this course and seeking out more information in those specific areas.